Hey, my name is Steve. Welcome back to my YouTube channel. This video will cover the 2019 HSC Mathematics Extension 1 past paper from question 1 to 5. So here will be the first question. What's the domain of the function? For any log function, this domain has to be greater than 0, which means we have 4 minus x greater than 0. So we bring the 4 to the other side to become negative 4. So negative x greater than negative 4. The both sides take off the negative side, we have x less than 4. We flip the sign to the opposite. So we have x should be less than 4. So the answer for the question should be A. So for the question 2, from the point P, here's the point P. Outside a circle, a secant and a tangent. So here is the tangent. Here is the secant to the circle in this diagram. So under the tangent secant theorem, the tangent square equal to the PB times the PC. So using this theorem to solve this question, we have this part tangent square equals to this part times this part. So that we have 2x squared equal to this part x times the whole part. If we x plus 9, we have x plus 9. So here we have 4x squared equal to x times x plus 9. So which is, the answer is D. Here we go. Alright, let's go to the question 3. Question 3 asks for what's the derivative of this inverse tan function. You find this formula from your paper. So here the formula is we're doing the integration, this part equal to the inverse tan function. So to this question, we do it the other way. So from the right hand side to the left hand side. So compare this inverse tan function to this formula. You can see this A should be equal to 2 from here. But we don't have a 1 over A in front of the inverse tan function. Then let's make it. So we make it to have 1 over 2 tan inverse x over 2. But how can we make this one equal to this inverse tan function? We have a half here, then we times 2 to make it this part equal to 1 of this tan inverse function. Then we can use this formula to get the derivative of the inverse tan function. So we have, so you can see this part is exactly the same over here. Then we can, this one equal to 2 times, using this formula to have 1 over, then A equal to 2. So we have 2 squared plus x squared. So we have, so put the 2 on the top, we have 2 x, here's 4 squared plus x squared. So the answer would be C. Okay, let's go to question 4. Question 4 asks you about one of these functions representing this diagram. So we have to look at this diagram very carefully. My suggestion to you is you can choose some specific points to test all of them to see which of them can match this diagram. For example, we can choose the origin 0x equal to 0, y should be equal to 0 as well. But all of them can meet this condition. X equal to 0, 0, 0, 0, y all can be 0 as well, which means it's nonsense. We can choose another point from here between 0 and 1. At this point, the y should be negative. And from here, we can see C and D. Here's positive, 1 minus x squared also positive. So positive over positive, y is positive. Doesn't meet the condition of the diagram. Then C can be eliminated. Also D, here's positive, 1 minus x squared also positive. So positive, positive, y is positive. So D should be eliminated as well. Then A and B are left. So see the diagram, when x goes to infinity, the y is approaching to 1, but we have to find the limit for these two functions when x goes to positive infinity. What's the y approaching? I will introducing the L'Hopital's rule to handle the limit of 0 over 0 or infinity over infinity, these two situations. Under this rule, the limit of this function equal to the derivative of the numerator divided by the derivative of the denominator as well. For example, for the question, for the A option, we have the limit x go to infinity of x over x squared minus 1. So this one, so be equal to the limit x go to infinity, the derivative of x divided by the derivative of x squared minus 1. Here you go. The limit they are equal. I will upload another video to explain these rules. But in the written question, you have to check with your teacher or with your school whether or not you can use this rule as well, because this rule is not available in high school. Okay, under here we have equal to the limit x go to positive infinity, the derivative of x equal to 1, divided by this one, we have 2x, right? So when x goes to infinity, this one is go to 0, right? And for b, so this one's a, so this one's b. So the limit for when x goes to infinity, x squared over x squared minus 1 equal to the limit x go to infinity, the x squared derivative over x squared minus 1 derivative. Oh, sorry. Derivative. So for here, we keep going. The limit x go to positive infinity, x squared we have 2x for the derivative, and here we have 2x as well. So 2x over 2x equal to 1. So when x goes to infinity, the limit of this function is 1, which means when x approaching to infinity, positive infinity, this function is the y is approaching to 1. Is approaching to 1. So B should be your answer. Okay? Okay, let's go to question 5. A particle starts from the rest and 2 meters to the right of the origin and moves along the x-axis in a simple harmonic motion. For simple harmonic motion, we have this equation x equal to b plus a cos nt plus alpha. And because this particle is starting from the rest, so we have b and alpha are both 0, which means here is 0, is 0 as well. This a represents the ambiguity of the particle. So we have 2 meters to the right of the origin. This 2 meters is the ambiguity of the particle. So for a we have 2, and for this n we have n equal to 2 pi divided by the period. And the question will show you we have the period for 2 seconds. So n equal to 2 pi divided by 2 equal to pi. So we have pi over here. So for this particle, we have the equation is x equal to 0 plus 2 cos pi t. Pi t plus 0. So we have x equal to 2 cos pi t. So the answer is A. For simple harmonic motion, is not in the 2020 syllabus, so you should not see this kind of question in the exam. And also the tangent tangent secant theorem as well. So in this question 1 to 5, question 2 and question 5 not in the new syllabus. Okay? Yeah, that's all for the question 1 to 5. If you like my video, give me a like and subscribe my video. In the next video, I will provide the explanation for question 6 to question 10. See you!